So this is from Thursday's in-class practice, right? So Thursday practice problems. Number 3. And I've got the function f of x equals x e to the minus x squared over 2. And so I want a second derivative. It's important that you look at this graph, right? It's important that you look at this graph. I'll do it on my calculator. And I've got y equals x e to the negative x squared divided by 2. And I graph it. And it's pretty close to that curve, so definitely I like zoom in here, zoom to, and right on the origin. You can see the origin, zoom to, why didn't it move? Frozen. Come on. Frozen. Oh, here we go. Nope. I can't waste time on it. Go to Desmos. I go to, so I'm going to graph this f of x equals x e to the minus x squared over 2. Oops. So there it is. It's so much easier to use Desmos. I'm so mad the school put me in a non-computer room, but it's what we got. So there it is. Do you see any top of a hill or bottom of a valley? Good, so that's my first derivative equal to 0. Do you see any place, drive on that road for me, can you see where you're turning your wheel? That's where my second derivative is equal to 0. This is chapter 4 material. First derivative equal to 0, I could have a top of a hill, a bottom of a valley, horizontal tangent, slope equals 0. Second derivative equal to 0 is where I'm changing the steering when I'm driving or changing the concavity. Do you see the first part of the curve looks like the corner of a frown? And then a smile. Do you see the smile there at the bottom of the valley? And then a frown again. Do you see the frown again? And then at the end, half of a smile again. Concave up is a smile. Positive people smile. Concave down, negative people frown, right? When the first derivative is second derivative is positive, we have concave up. When the second derivative is negative, we have concave down. And in between, we could have what's called an inflection point. So I have a product rule here. First function is x, derivative is 1. Second function is e to the minus x squared over 2. Derivative is negative 2x over 2 e to the minus x squared over 2. So meaning e to the x, we know the derivative is e to the x, right? But keep the cat in the box, yes? And then the derivative of the inside. Do you see the inside? There's the inside. Men, you agree? Inside? What's the derivative of that? Well, it's an x squared, so it becomes a 2x, right? And then the 2's cancel, of course, right? Good. I put this together for my first derivative. So f prime of x. I'm going to pick this piece first because it's positive. When I'm doing product rule, I'm allowed to do that. I get e to the minus x squared over 2, and then I get a minus x squared e to the minus x squared over 2. right? That's this part, yes? I want to factor it, so I see I can factor out an e to the minus x squared over 2, and I get what left, 1 minus x squared. Oh, that factors even more, doesn't it? I get 1 plus x and 1 minus x, yes? Everyone agree? What are my critical values? Plus and minus 1, right? When you factor, it's really easy to see the criticals. In this case, it wasn't so much easier, but definitely I can see the criticals here. And so, yes, Aaron?
Minus x squared.
Yeah, so you definitely see the negative, right? And then there's an x times an x.
Oh, okay.
Right? So what is this saying? It's saying I could possibly be at the top of a hill or the bottom of a valley at plus and minus 1. Look at the picture. Do you see it? Do you see it at plus and minus 1? Yeah? And of course, on Desmos, which is really nice, I can plot them pretty quickly. So minus 1 comma f of minus 1. There it is. There's the, right? You see it? Nice. Second derivative. It's not always so clear which one of these I should do for my second derivative. So it's good for you to practice a couple of them and see, should I use this one? Should I use this one? Should I use this one for my second derivative? I actually probably like this one for my second derivative, but you should try them all. The last one really sucks for a second derivative. So I'm going to use a product rule again. First function is e to the minus, Kirk, okay though, so far? Yeah. First function in my product is e to the minus x squared over 2. I already did that derivative, it's here. It's minus x e to the minus x squared over 2. And second function in my product is 1 minus x squared. Derivative is negative 2x. We okay here? Yes, we're okay? Good. So, and I like to, right, I like to kind of box this stuff up, right? I know this is my quotient loop for f double prime, right? This is my quotient, sorry, not quotient loop, product loop, right? In this case, I see both pieces are negative, so it doesn't matter which one I pick first. I'm going to pick this one first. So I get a negative 2x e to the minus x squared over 2. And then I get a negative 1 minus x squared e to the minus x squared over 2. Putting in, oh, times another x, right? Sorry. Yes? Yep. And so I see I can factor out a negative x e to the minus x squared over 2. Agreed? I can factor, I see I have a negative in both. I have an x in both. I have an e to the minus x squared over 2 in both. I can factor that out. And then what's left over? What's not highlighted? 2 plus 1 minus x squared, right? And so that is, so this is, so I get negative x e to the minus x squared over 2 plus 3 minus x squared. Notice I can take out a factor of negative from inside, right? I can factor out this negative here, and it will cancel with this one. So my final answer, almost, is x e to the minus x squared over 2 times x squared minus 3. I can factor that last piece a little bit more. Do you see it? I have a difference of squares. I'm squaring x and I'm squaring rad 3, right? So I can finally write x e to the minus x squared over 2 times x plus rad 3 times x minus rad 3. Done. I want things factored, all derivatives factored. What are my criticals? Yeah, plus or minus square root of 3 and 0. if I go back to my graph, and I'll go back to that screen in a second, I can graph 0, comma, f of 0. It's obvious what that is, though, right? There's a place where I'm changing from concave. You see it, concave up, smile on the left side, frown on the right side. I'm changing my concavity at 0. What's the other one I got? I got a negative square root of 3. Oops. Comma, f of negative square root of 3. That purple spot, I'm changing my steering as well. Right? You see it? Turning the wheel to the right. Turning the wheel to the left. Turning the wheel to the right. Yes? Yes, you with me? Let's take a look at some chapter 3 tests. Yeah, sorry, go ahead.
So I know you get product rules when do we know that we don't do it? Because I've seen you do to power something like that.
Yeah, but that's not a product. E to the some power is an exponential function, right? So I'm not multiplying e to the something times something else.
So we would just do a power to the e?
No. Look at the one I did, right? That's a product with this, right? Those are both factors. So if I'm multiplying things, I use a product rule. When do you use a product rule? Only when you have a product. When do you use a quotient rule? Only when you have a quotient. When do you use a chain rule? Always. Forever and ever and ever. Always do the chain rule. For the rest of your mathematical life. You have to think about things are changing inside as well. Let's look at some old exams. Let's see, there's 1, 2, 3 clicks. Oh God, 4 clicks. It's gonna ring in my ears really loud, I know it. Five clicks, 6 clicks, 7 clicks. I'm just trying to show my computer scientists here how bad Blackboard is as a website, and please, someone go work for them and fix it. 7, 8, 9. That's a current semester in our class. 10 clicks finally. And then inside of my chapter 3 folder, I'm looking at the fall 2019 chapter 3 test. Look at number 8. Write this down, please. Fall 2019 chapter 3 test. Do not do number 6. Do not do number 11. Fall 2019, do not do 6 or 11. I'm going to teach you how to do 6, but I'm not going to put it on the test. Okay? Fall 2020. Do not do number 6. 6 and 11 on the 2019 chapter 3 test from fall. And from fall 2020, do not do number 6. Again, I'll teach you how to do it, but don't bother doing it. It's not going to be on the test. Say again. One more time. 2020, fall 2020.
And not the 6.
Don't do 6 on either one, yeah. Let's go to midterms. Fall 2020 midterm. Whew, that was short. It says in number 4, it says use the LN trick. The LN trick is the piece I'm going to teach it to you, but I'm not asking you to do it. But you could do that with product rule. Do you agree? Number 4? Yeah. Your test will look a little short. It will look short. But I plan on having 10 problems on it. There might be a problem with 2 parts, right? For example, number 1 here is find the derivative. Find the limit algebraically and using L'Hopital. So that's 2 problems, right? Number 2 is 2 problems. Find the derivative using a limit and using the quotient rule. 2 problems. Number 3, find the derivative of secant of y minus x equals 1 over x in terms of x. Remember, you need a triangle there. And then find the second derivative. This is a good test. It looks short, but it's a beast. Teeth, sharp teeth. We'll do a couple of those today, okay? I like that midterm. Let me look at. Say again? Yes, yes. Don't not use the LN trick. Use product rule though. Let's look at summer 2019. Yeah, so summer midterm. Don't do 3 and 4. Summer 2019 midterm. Don't do 3 and 4. Don't do 10. Don't do 13. Yep. Summer 2019 midterm. Don't do 3 and 4.
For fall 2019 and fall 2020, no 6, 11,
And no 6.
no 6 is that for
Chapter 3 test.
Okay.
So what did I say on this test? No 3 and 4. No 10. That's the LN trick again. No 13. That's enough. If you do all those, you're ready. 2 chapter 3 tests, 2 midterms. Do them all. If you're having issues with speed, do them thinking, I'm giving you 2 hours, 120 minutes. I'm giving you 10 problems. That's 12 minutes a problem, right? So you 15 minutes before you're leaving for a movie or whatever, or leaving for dinner or whatever, you say, all right, let me do 1 problem and see if I can get it done in that time. Yes. And so that would be 24 minutes. Yeah. What's up, Jeffrey? You okay? All right, let's do our new stuff. Here we go, finally. Let me look at what we did last time. We did our inverse trig derivatives, so we got to practice some of those. Let me remind you what formula sheets and process that you need for these inverse trig derivatives, right? So I'm doing 181, Tuesday, Thursday, week 6, class 1, yes. Let's just do a quick schedule, sorry. Our schedule is week 6, week 7, week 8, Tuesday and Thursday. So we're going to have quiz 9 through 12 on Thursday, just like that handout I gave you, right? Just like the handout I gave you on Thursday. Week 7, we're going to have homework 4 due, right? We're going to review only on that Tuesday. We're going to review all of chapter 2, all of chapter 3. Say again? Oh, I can't, I'm sorry.
There's no chapter 1 in it.
No chapter 1. Chapter 1 is pre-cal. You took pre-cal. I'm not teaching you pre-cal. You have to know it, right? I know I'm being a jerk, but can't help it. I was born that way. Homework 4. So next Tuesday, homework 4 is due. We're going to review only, no new material, right? And then on that Thursday, we're going to take our midterm exam. I will do my best to post midterm grades by Friday, and I will send out an announcement. It will have your quiz average, your homework average, right? The one test. It'll assume the project is perfect. It'll assume you're doing your study groups, and I'll calculate your actual grade. I do have to turn in a midterm grade for you, based not just on the midterm, but everything. And the midterm grade is really meant to do two things. Help your advisor plan your next semester. So if they see you're doing really well in Calc 1, they'll say, okay, let's put you in Calc 2, right? And the other thing is just to light a fire. If you see that you have an F, you know, you gotta do something. Quizzes on 3.2, product rule, chain rule. 3.3, trig derivatives. 3.4, chain rule. I might also have a tangent line on there. Doubtful that I'll put a derivative using a limit on there, but it's on my mind because some of you can't do it still. So, and then week 8, spring break. I think spring break, and don't trust me on it, takes over both Saturdays. So if you're on campus on a Saturday, working or taking a class, anybody working or taking a class on a Saturday, double check with the academic calendar. Does spring break eat both of those Saturdays? Right? Does that make sense what I'm saying? So just double check. And if you're working, talk to your whoever's in charge, right? Nice. All right, here we go. Recap of 3.6 inverse trig derivatives. Of course, right, we're just going to do a quick review here. If I look at the arc cosine of pi over 3, right? Anybody? I'm sorry, arc cosine of 1/2, sorry. Silly Robert. Anybody know the answer? I already said it. Pi over 3, right? Because what? Cos of pi over 3 is what? 1/2. This is what an inverse trig is, right? It changes the input and output, right? They switch, right? You with me? Yep. So we know what an inverse trig is. We derived the arctan, right? I asked you to derive the arcsine, did I? So we know arcsine of of x is my function y. I want to find this derivative using implicit differentiation, but I don't know what to do. So I realize I can take the sine of both sides here, right? I can take the sine of both sides. I can take the sine of the arcsine of x, and that should equal the sine of y. What happens on the left-hand side? What do inverse functions do to each other? They cancel, right? So I just get sine of y is equal to x. Everybody with me there? Inverse functions cancel each other out, right? Square root of x squared, they're inverse functions. What do you get? I get x, right? X plus 3 minus 3, what do I get? Adding 3 and subtracting 3 are inverse functions. What do I get? X. You always get x when you compose inverse functions with each other, right? So now I know how to deal with sine because I know the derivative of sine. But remember what I said. When you see a trig, you also see a what? A right triangle. So when I see a trig, I see a right triangle. In fact, when I see an inverse trig, what do I see? When I see an inverse trig, what do I see? Oops. Say it again? Yes, if I see an inverse trig, I see a triangle. Right? These are thoughts that you should have. Oh, can I draw a triangle here? I might not need it, but let me draw it. All through Calc 2. You need this thought. You need to be able to draw these triangles. So sine it's now got an angle of y, and the opposite over hypotenuse is x over 1 for sine, right? Height over hypotenuse, yes? X over 1. I have to figure out the other side using what theorem? Pythagorean theorem. Known in ancient China 4,000 some years before Pythagoras. In ancient Egypt, even further back. Right? But Pythagoras is the one who published it, kind of. So, so the remaining side is square root of 1 minus x squared. Does anyone want to see it? Anyone want to see me use the Pythagorean theorem there to get that side? You serious? You don't want to be honest with me today? You don't want to talk to me? It's not an embarrassment to say, yes, show me. There's nothing wrong with me showing that. Anyone want to see it? Thank you. So that remaining side I'm going to call C. I'm sorry, A, right? A squared plus x squared has got to equal 1 squared. Pythagorean theorem, right? So a squared plus x squared has to equal 1. So a squared must equal 1 minus x squared. And so a is, when I take a square root, I usually do the plus minus, but I don't care in this case. I'm going to always assume I'm in quadrant 1. So square root of 1 minus x squared. Thank you, Sina. So I got my triangle done. I don't know if I need it. I might. You'll see in Calc 2, one of the most difficult problems we do is called trig substitutions. So we take an expression in x and turn it into sines and cosines. And then the antiderivative is easier. Here we go. We're ready to keep going here. I want to do d dx of sine of y, and that should equal d dx of x. Right? I'm taking the derivative with respect to the independent variable x. On the left-hand side, I know the derivative of the outside function. That's cosine, yes. I want to keep y inside, but then I have to do times y prime, derivative of the inside. On the right, what do I get? 1. Nice. Remember, I'm solving for y prime. So I get y prime equals 1 over cos of y. That might as well say secant of y. Agreed? Yes? 1 over cos is secant? Yes? Are they inverse operations? No, they're not inverse. They're called what? Reciprocals. And I can go to my triangle and find the secant, right? There it is. There's my secant. Yes? So that's 1 over square root of 1 minus x squared. There's my derivative of the arc sine. Let me write the summary, right? I'm going to write each one twice. I really want the second one is what should be on your formula sheet. So my summary here of the only 3 inverse trig derivatives I'm going to give you come from y equals arctan of x. And from that, we get y prime equals 1 over 1 plus x squared. I derived that one last week. Y equals arc sine of x. This one I just did. Gives me y prime is 1 over square roots of 1 minus x squared. And arc cosine, which I usually don't give, but I just listed here anyway. This one gives me the opposite derivative of arc sine, so minus 1 over square root of 1 minus x squared. Those are the only 3 I ever ask you about. Really, it's just the first 2, arctan and arc sine. So if you see a problem with arc secant, not doing it. Arc cosecant, not doing it. Arc cotangent, not doing it. We'll wait for Calc 2 to do those. Those are not the ones I want you to know. I want you to know these. If y equals the arctan of u, this is the one I want to memorize or put on my formula sheet. Y prime is u prime over 1 plus u squared. And what do I need here to fill in this derivative? I need u. I need you. I need u prime, I need u squared. Then plug and chug. That's all you have to do for these. What's my second one? Y equals arc sine of u. And what do I get? I get y prime is u prime over square root of 1 minus u squared. Those are the ones I really want you to know. In fact, all your derivatives, right? All your shortcuts should have a function inside now, right? Is that making sense, what I'm saying? Every single derivative you know should now have a function inside, right? So meaning y was e to the x. What do we get for y prime? Do you remember our shortcut? E to the x, right? But now I want you to have this down, y equals e to the u, and what's our derivative? U prime e to the u, right? I need that chain rule piece in every one of my derivatives. Make sense? Every single one of my derivatives. We used to have memorized y square root of x gives me what? Y prime is 1 over 2 square roots of x. But now we want to think of square root of u, right? And what is now y prime? We're still 1 over 2 square roots of u, but times u prime, right? Derivative of the inside. We have to be thinking of that every single time we take a derivative. Nice. Let's do a couple problems. Yes? Yes. To above? Previous one where I was deriving that. Yeah. And again, you're not going to have to derive it. You gotta do three things. Four things. Find u prime, find u squared, plug and chug. Do some algebra. That's all you have to do. So when I'm giving you this I'm showing you how we came up with it, and now I just want you to use it, right? You don't have to know how to build a car to drive it, okay? Right? You agree? So I built it for you. You just drive it, right? All right, let's do a couple problems. We ready? Yes. The schedule? No, this one. Yes. Brian.
So for the derivatives, I know that it gives you the slope of the slope, but
The slope of the curve.
yeah, slope of the curve, the chain rule is different from that.
No, chain rule's still giving you the slope of the curve.
So it gives us the same graph.
It's a derivative. Yeah. The chain rule, and we've been doing the chain rule all along, right? I said to you a long time ago, y is the square root of x gives me y prime is 1 over 2 square roots of x times the derivative of the inside. But what is the derivative of x? 1. So I haven't told you you've been doing chain rule. You've been doing chain rule. You always do chain rule. I gotta sound nuts on this recording, I'm sure. But you always do the chain rule every single time you do a derivative, Travis. Yeah. Yeah, it's so I think you got that already, because it's just gonna do what? It's gonna put another negative in front of it. Right? And think about my wheel for cosine and sine, right? Cosine going past sine gets the negative, so our cosine gets the negative. I'm in trouble a little bit for giving you a formula sheet. My supervisor is saying I shouldn't. And I said, well, I'm already going to fail 50% of the class. So do you want me to fail 80% of the class? It's a lot to remember. I think it's too much to remember. So that's why I give you a formula sheet. But that formula sheet has got to be your answer to how to do things. You've got to have some notes on there. You've got to have some insights on there. What the hell does it mean to find a derivative using a limit? You have to, right? When you're practicing these old exams, when you're doing things, make sure you're working on your formula sheet. I want to collect it for the midterm. I want it to be a piece of art. I want to be able to frame it and put it up on the wall. It should look that good. If you need help getting multiple pages onto it, I can help with that, right? Like if you emailed it to me, if you email me 8 pages and in a PDF, please, I could get all 8 pages on the back and front of a single page. I could do more than 8, and I'll allow a magnifying glass too. How's that? I'll allow is one formula sheet and a magnifying glass, right? You can have music on when you take your test. No one else should be able to hear it. I used to hate when someone next to me was sniffling or tapping their pen. I like you to be able to block distractions out, right? So you have the formula sheet, you have your music, right? You have your calculator, right? And you don't need any paper. I will give you paper. The exam will feel like a book. It'll be 10 problems, 10 pages, some extra paper in the back, right? So when you come in that Thursday, we start right at 9 o'clock. There'll be no office hours that day. The room will still be open. I will not be here until right when the exam starts. You don't need to be fussing around with anything. Either you know it or you don't, right? So you got some serious practice to do. Probably a good 15 hours this week, maybe another 5 or 10 at the start of next week. After you take your midterm, you're done. You take spring break off. No math, please. Okay. All right. Let's do a couple problems. Some easy, some tough. Okay. These are examples. Get it? Little joke. Examples. Y equals the arc sine of x over 2. I see an inverse trig. That means I see a trig. That means I see a right triangle, right? I don't know if I need it, but I don't like to think in terms of inverse trigs. I like to think in terms of trigs. When I'm talking about trigs, I like to think in terms of sines and cosines, right? So, but anyway, what trig do you see? Yeah, sine of y is x over 2, right? I don't know if I need the triangle, but I'm going to just put it up here anyway. There's an x, there's a 2. The remaining side is 4 minus x squared. Again, with Pythagorean theorem. I don't know if I need it, but I have on my formula sheet, if I see an inverse trig, that means I see a trig. That means I see a right triangle, and I can label the sides. It doesn't look like I need it on this one, because I know on my formula sheet, I have y equals arc sine of u gives me y prime is u prime over square root of 1 minus u squared. So all I'm seeing is, I need u. I need you. I keep saying that's funny to me. We use u as our inside sub. So f of x becomes f of u, and I think it's funny. It sounds like I'm cursing a little bit. F of u, right? So u subs, you'll hear that quite a bit this semester. So all I need is u. What is u? Anybody help me? Yeah, beautiful. What's u prime? 1/2, yeah. It's that easy, right? mx plus b, do you see it? X over 2 is mx plus 0, 1/2 x plus 0. Slope is 1/2, right? And what's u squared? I know it's tough. X squared over 4. X squared and 2 squared, right? And now plug and chug. 4-step process. Actually, 5-step. 4-step. Right? Find u prime, find u squared, plug and chug. So what do I get for y prime now? So this is all side work, right? What do I get for y prime? I get 1/2 over square roots of 1 minus x squared over 4. Am I done? The calculus is done. Am I done? No. You see a fraction or more within the fraction. And I always want a single completely factored fraction. Yes? So what I'm going to do is I'm going to factor out that 4 downstairs, right? I'm going to pull that outside of the square root, right? And I can kind of do this first anyway. I'm gonna go slow with this because I know some of you aren't going to like it. I'm going to get an LCD here first, right? Yes, you with me? So I've got 1/2 over the square root of 4 minus x squared over 4. Do you recognize the square root of 4 minus x squared from anywhere? Do you see it anywhere else on the page? Just say yes. Just lie to me and say that you see it. Yeah, it's on the triangle, isn't it? It's not a coincidence. Not a coincidence. So that downstairs 4 comes out of the radical as a what? Yeah, a 1/2, right? So I have a square root of 4 minus x squared all over 2, right? So there's a 1/2 upstairs and a 1/2 downstairs. Do you see that? Right? So final answer is what? 1 over square roots of 4 minus x squared. And Brian was asking this before. Brian S. Brian D's not here. Brian was asking, oh, I have a radical downstairs. Don't I have to rationalize it? No. Not anymore. And if I do rationalize it, anybody rationalize that in your head? Anybody do that in your head? Square root of 4 minus x squared over 4 minus x squared. You see how many more pen strokes there are? How many more characters there are? Mm-hmm. So no, we don't do it. It's u prime. I already did my calculus. I did my calculus here. Right? Find u prime, find u squared. Done. Plug and chug. Make it look nice. No more calculus. Once I plug and chug, I'm not taking derivatives of anything. I took my derivative. I got u prime, I got u squared. Plug and chug. That's it. It's hard to accept. It's hard to build a car. Easy to drive it. Just drive. Find u prime, find u squared, plug and chug. Make it look nice. Quotes, nice.
How did you go from the square root of 4 minus x squared divided by 4 to, is it the square root of 4 minus x squared?
This guy?
No, above that, the 2 above it.
Yeah, so this square root, see that 4 is inside the radical?
Yeah.
So when I take it out of the radical,
Oh,
yes.
Okay.
Yep.
Okay.
Ready? Next one. We did this one last class, but I want to do it again anyway. I've got y equals the arctan of x squared. You know what the tangent function looks like. When you took pre-cal and you did all that graphing of trigs, you also learned how to do an inverse function in pre-cal, which means I change the x's and y's. That's the same thing as, imagine me switching x and y, right? If I switch x and y, can I just do this? Can I put my x-axis up here, my y-axis here? You see it? Yes? Mm-hmm. But the problem is now, right? The problem is y's are positive over here. So once I rotate it this way, I have to flip it around completely to get things back in the right orientation. And that's the same as reflecting about the line y equals x, right? So if I take this guy and reflect around the line y equals x, right? I'm going to get this guy. Oops, arctan. So there's my arctan. What's the domain of arctan? It's everything, right? Every x, right? You see how wide it gets? Goes forever. What's the range of arctan? How high does it go? How low does it go? We got asymptotes, right?
pi squared.
Pi over
I mean, yeah, pi over 2.
pi over 2, plus or minus pi over 2. Look at tangent. What's the domain of tangent? I'm not supposed to be teaching you pre-cal, damn it. What's the domain of tangent?
Pi over 2.
Anywhere from minus pi over 2 to pi over 2. What's the range? Infinite, right? Up and down. They switch inverse functions, switch x's and y's, domain and range. But now I'm going to square, I'm going to put an x squared inside of arctan. What is that going to look like? You remember? It's going to take all those negatives and make them look like positives. Driving on this road, you can see my second derivative has some zeros. Do you see it? Drive on that road. Are you turning the wheel at all? Second derivative should have some zeros. Good. Let's find y prime. So what do we know for arctan? Right? What do we remember? Y equals arctan of u. I get y prime is u prime over 1 plus u squared. All I need to do is find the function u, find the derivative of the function u, square that function u, and plug and chug, right? So what's u? X squared, nice. What's u prime? Nice. And what's u squared? X to the fourth. Beautiful. Plug and chug. I get 2x over 1 plus x to the fourth. That's it. It's that easy. These are easy. But you have to accept the first part. You have to accept the first part. It's not easy to understand it. You don't have to understand it. You have to try. That's the hard part, is you have to trust me that I'm teaching you the right thing. That's the hard part. Right? I mean, look at me. You can't trust someone that looks like me. You can, but why bother? So don't waste your time doing that with the triangle. Well, try it. I mean, yes, do it. So here, y equals arctan of x squared gives me what? Tangent of y is x squared, right? So the triangle now looks like x squared over 1, and this side would be square root of 1 plus x squared.
No, it's 4.
Oh, what?
Yeah, it's 4 to the third of that.
Oh, x fourth. Yes, Min, you were right. Sorry, thank you. And look at the answer. Do you see that part of the triangle there? Do you see the hypotenuse there? Do you see 1 plus x to the fourth? Yeah. When you do the derivative with the triangle with the implicit, what do I get for the derivative of tangent? Secant squared. Nice. Good. Nice. So we did the second derivative last time. Make sure you do that again. With this one, I love it. I love that problem. Let's move up a level. This is easy, right? Yeah. Easy, yes? Is it easy or no? Yeah, you might be a little bit confused, but it's not like I'm doing something that's like impossible. In fact, I don't do anything that's impossible, right? All I'm doing is math, really. And all we need to do, math, is be able to add, right? Multiplying is just adding, right? So we're not doing anything difficult. Walking to California is difficult, but no single step on the way is difficult. There's a couple of mountains there every now and then, but right? No single step I do is difficult, but you have to practice. And you got to start the right way. You can't start walking to Florida. I mean, you can, but we want to start the right way, right? All right, let's do a tough one. This is from. What is this? This is the 2019 summer midterm. Look at number 5. Find the second derivative, right? Let's do number 7. The tangent of the arcsine of x over 2. We want to find y prime. So y equals the tangent of the arcsine of x over 2. If you remember, we did the derivative of arcsine already today. Right? Say it again? So I see a tangent. Do I see a function? Do I see a triangle? Yes and no. The problem is here, if I'm going to label my triangle, it's going to be labeled with what variable? Perla, just make sure it doesn't shut all the way. Oops. What's going to be the label on my triangle, x or y? It's going to be a y. It says tangent of something equals y, right? So I already know y over 1 for my height and base of my triangle. But that's not what I want. I want things in terms of x, right? So, but do you see an inverse trig? Do you see an inverse trig? Okay, if you see an inverse trig, that means you see a trig. And that means you see a right triangle, and that means you can get all the sides. So I always want to kind of be thinking of my inverse trig as a theta. So theta is the arcsine of x over 2, which means sine of theta is x over 2. There's my triangle. When I see an inverse trig, I see a trig. I see a triangle. If I see a trig, I see a triangle, right? But be careful, right? Kind of, please excuse my drunk Aunt Sally takes over here. The inside is where I have to focus first, right? So my triangle is the same one I did before, right? Of what? X and 2 and square root of 4 minus x squared. Same triangle as the previous, when I did it earlier, right? That's okay? Mm-hmm. Anybody else okay with that? I got 3 nods. 4, 5, 6, 7, 8. Nice. That's enough. I want to take my derivative now. So I have a triangle. I don't know if I need it. In this case, I do need it. In the other case, I didn't need it, right? So, but I don't know at first until I do enough problems, then I know. So, but we're going to take our derivative. We want to find y prime in terms of x, right? That's another hint that you would not want a triangle with sides of y. So we're going to do ddx of y is going to be ddx of tangent of theta. I don't feel like writing arcsine of x over 2. I know what theta is. It's arcsine of x over 2. So what do I get on the left? Nice, y prime. On the right, derivative of tangent is secant squared theta. Keep the cat in the box, times theta prime. Nice. Theta prime is the derivative, right, of arcsine of x over 2. And what's our process for an arcsine of x over 2? Find u prime, find u squared, plug and chug. So I get y prime is secant squared theta times, what's my value of u? Yep, u is x over 2. U prime is 1/2. U squared is x squared over 4. So I get 1/2 of the square root of 1 minus x squared over 4. I'm pretty sure we remember what that turns into. Do you remember? Yeah, the 1/2, remember the 1/2's canceled? and then right? So I did this work before, I don't feel like doing it again. But I know I get 1 over the square root of 4 minus x squared, right? We did this problem already today, yes? But not with the secant squared. Where am I going to get the secant squared from? From the triangle. Secant is what ratio? Hypotenuse over adjacent. So 2 over square root of 4 minus x squared, but quantity squared, right? So I'm going to get 2 over square root of 4 minus x squared, quantity squared. Am I done? No, I have fractions inside of fractions. Or better than that, I have 2 fractions, right? So I get 4 over 4 minus x squared times 1 over square root of 4 minus x squared, which is final answer 4 over 4 minus x squared to what power? 3/2. Very good. There's a bunch of problems like that in the old exams. Make sure you do them all, right? Make sure you do them all. I'm going to put a different one on your test. So when you're doing process, when you're writing your formula sheet, you need step-by-steps that you understand, right? You should also have a problem, a completed problem on there. What if he gives me one like this? Well, let me see what he did on the answer sheet, right? From the midterm from last semester, the kind of thing, right? Say again? Yes. Is that okay? Let me numbers, okay? Let me number. Where are you?
Yeah, how do you get from 7 to 8?
Yes, so I realize I'm doing, am I in the right spot? I realize I'm doing theta prime here, right? And that's this derivative. When you're doing a derivative of an inverse trig, you find u prime, you find u squared, you plug and chug.
So that theta is like sin theta?
Oh, let Berlin please. Say again?
Is that theta like it's sin theta?
Yes. Theta is arc sine of x over 2 is same as saying sine of theta is x over 2. Sorry about that, Berlin. Is that what you're asking me, Min?
Yeah.
Yes. Let's do another. Yeah? Yes, I got one. Answer.
How do I get the 4 minus x squared to the power of 3? The derivative, right?
Yes, so this is something to the first power. This is the same thing to the half power. When you're multiplying like bases, what do you do with your exponents? You add them. So 1 plus 1/2 is 3/2. Right? A times square root of a is a to the 1 times a to the 1/2, which is a to the 1 plus 1/2, which is a to the 2/2 plus 1/2, which is a to the 3/2. Yep. And you can always ask anything. I remember asking a question to my topology teacher. Topology is mapping of surfaces to surfaces, like a coffee cup is the same as a donut, right? Coffee cup is the same as a donut. You agree? The handle of the coffee cup is the hole in the donut, right? And then where I pour the coffee, I can push my finger into the donut to make like a cup part. So that was the math I studied in college. How do you map surfaces to surfaces? And so I remember asking a question like, it was something stupid, and the teacher was like, oh, it's just this plus this. And I'm like, oh. And it's okay. You can ask any question, right? Any question. Yes?
Like how do you turn the square second to the like 90?
Yes. So I go back to my triangle. Once I see a trig, I had better have a triangle, right? And secant is the ratio of 2 over square roots of 4 minus x squared, but it's secant squared. So take that ratio and square it. Let's do another. Mm. 5 is interesting. 7 is interesting, right? I don't know if you can tell. I don't know if you can tell that in 5 I don't need a triangle, in 7 I need a triangle, right? But we can do those. What time is it? 10:30? Perfect. That's the thing about Monday, like 2-day-a-week classes, Monday, Wednesday, Tuesday, Thursday classes. If it's 5 credits, it's long. It's long. Like I said, I don't like taking a break. I'd rather leave early. But of course, if you have to use the restroom, if you have to make a phone call, just go, right? And if I only shut the door because I could hear the other teacher. But you know, if you leave, feel free to knock or just prop the door open a little bit, right? It's your classroom. You do what you want. It's your life, right? Let's do 5 here. I want to find the derivative. I want to find f prime of arc sine of cos of x, right? Arc sine of cos of x. Of course, if it was arc cosine of cos of x, that's a funny one, right? Arc cosine of cos of x. Anybody know the derivative? What? 1. Ah,
Because the derivative x is 1.
that's right.
That
So
arc sine.
arc cos and cos are inverse, so you just get x, then the derivative of x is 1. Right? And it's funny, if you go into the formula that I gave you, find u prime, find u squared, plug and chug, you'll still get 1. Maybe I'll do that, but let's do this one. What's the formula I have memorized or tattooed or on my formula sheet? Y equals the arc sine of u gives me y prime is u prime over square root of 1 minus u squared. Good. All I have to do to play this game, and I have it written down on my formula sheet, is find u squared, find u prime, plug and chug, right? So what did I get for u? Cos of x, yes? Just what's that inside function, right? Yep, cos of x, right? What's u prime? Nice, negative sine of x. And what's u squared? Cosine squared, right? Nice. Plug and chug. So f prime of x. What's u prime? Negative sine of x. What's u squared? 1 minus cos squared of x. Oh, what's 1 minus cos squared of x? All my star trig students should know instantly what 1 minus cos squared of x is. If you don't, thank you. If you don't, I have no idea how you would not know 1 minus cos squared of x is sine squared. I have no idea how you would not know that. So I get minus sine x over square root of sine squared x. What happens there? Downstairs is square root of a square, so I just get the, right? So I get minus sine x over sine x, so I get negative 1. Is it a coincidence? No. I'm talking about that other problem. Didn't need a triangle, right? Didn't need a triangle here. In fact, if I tried to create a triangle, it gets crazy right away. You know right away you're not going in the right direction if you try and create this triangle. Right? Think about it. What could I say here if I was trying to create a triangle? Well, I could say the triangle's from cosine of x, but I don't have it equal to something, so I don't have ratios, right? So I could take the sine of both sides here, and I'd get sine of y equals cos of x, and now I'd be labeling the sides of my triangle with trig functions. It'd be weird, right? Okay, but let's do the next one. This is y equals the secant of the arctan of x over 2. I see an inverse trig. I think I see an inverse trig that's going to give me a triangle that makes sense, right? So what do I like to call inverse trigs? I like to call them theta, right? Because the domain of secant is an angle, right? Yes? So theta should equal the arctan of x over 2. But I don't like to think in terms of inverse trigs. I like to think in terms of trigs. So I'm not going to be thinking about arctan. I'm going to be thinking about tangent, right? So tangent of what? Yep, tangent of theta has got to be x over 2. Oh, but I know what tangent is. It's the ratio of the height and base of a right triangle. So that's x over 2. And then by Pythagorean theorem, I get the other side is square root of 4 plus x squared. How are we doing there? You make sure you do all these problems over. You make sure you do that last Thursday's practice problems over, right? I can't believe more of you didn't want me to do some of these problems. But it's okay. It's fine. It's up to you. I'm ready to take a derivative, but I really want to take d dx of y equals d dx of secant of theta. I don't want to write all that. I already know I'm calling my inverse trig theta, right? Yes, everybody with me? One person. 2, 3, 4, 5. I got several no looks, a couple that go to hells. Just shut up. So on the left I get y prime, yes? On the right, what's the derivative of secant? Nice, secant theta, tan theta, right? Times theta prime. Derivative of the inside for the rest of your life. You ever have those days you don't eat and you're just dragging? You ever have a day like that? Every Tuesday and Thursday? You're dragging because you haven't eaten. You know what I mean? Lack of energy, yes? So you're outside, you're changing. How are you moving around? Pretty slow, because how's the inside changing? Not much at all. Nothing in it, right? Your body starts to eat itself. Right? Do you know that? Isn't that a crazy thought? And what does it start to eat? The fat or the muscle? The muscle. Right? So if your body is eating your own muscle, do you think you're going to be moving well? Chain rule. It's crazy. Good. How do I get theta prime here? Yes, but it's an arctan problem, right? So I need u squared. I need u prime. Yes? What is u? X over 2. What is u prime? 1/2. What is u squared? X squared over 4. So I get 1/2, right, over 1 plus x squared over 4. I can get my secant and my tangent from the triangle. Who's got the secant for me? I need secant. Remember, I want my derivative in terms of x. That's where I started. That's where I would like to end. So what's my derivative? So what's secant by my triangle? Yeah, 2 over square root of 4 plus x squared. What's the tangent? Tangent of theta, please. Stop messing around. Stop messing around. It's really easy. X over what? Yep, x over 2. Look at the triangle. Tangent. Times a 1/2 over 1 plus x squared over 4. Am I done? Is that the final answer? No. Right? So I see a couple of things that cancel, right? And then I have to deal with that 4. Yes, you with me? So it looks like my 2's will cancel here. Yes? And if I start rewriting, I can definitely see I have
How do you calculate the second?
the secant.
Yeah.
Yeah, look at the triangle.
Is it not square root of 4 plus x squared
Oh,
over 2?
I did it upside down, didn't I?
Yeah.
Thank you. Silly Robert. Thank you. My teachers used to say they made mistakes on purpose to see if anyone's paying attention. Right? But I'm flawed. I've got flaws. Thank you. Secant is right, hypotenuse over adjacent, right? So it looks like I get x square roots of 4 plus x squared over 8 times 1 over 1 plus x squared over 4. Still not done. Right? Does everyone agree with the 8? There's an over 2, there's an over 2, there's a 1/2. That's 2 times 2 times 2 downstairs, right? Good. What am I going to do here? What's my plan? LCD? Keep, change, flip? 2 times 2 times 2. 2 times 2 times 2. Yeah. I want an LCD, yes? What is it? 4? Yes? Agreed? So that downstairs 4 moves where? Hello, keep, change, flip. Where does that downstairs 4 move? Upstairs, thank you. I get 4x square roots of 4 plus x squared over 8 times 4 plus x squared. Am I done? No. 4 over 8 is 1/2. Rad x over x is? Rad x over x, yes? Rad x over x, yes? That's rad x over rad x, right? That's 1 over rad x. The calculus is easy, the algebra sucks, right? Which is why I'm worried about the algebra. I'm worried about, like, when I went to school, back to school, after I dropped out, 7 years of teaching guitar and working in a restaurant, trying to make it as a rock star, I decided I would go back to school and I had to start again in 8th grade, which would be like our Math 50, right? Where you learn how to factor and you learn how to do with functions. You learn how to clear fractions. You learned how to use the quadratic formula. You learned the Pythagorean theorem. And you practiced and practiced and practiced. You learned how to graph a line, y equals mx plus b, right? That's our Math 50 class. And then you took trig and pre-cal, where you learned all kinds of polynomial functions. You learned rational functions, radical functions. You learned trig functions. You learned inverse trig functions. You learned exponential functions. You learned logarithmic functions. You learned inverse functions. You did all of that. And then we've been torturing you with it. And now you're finally ready to take calculus after you've done all that. All right. Let's look at the last section where I'm doing something called an LN trick. I am not testing you on this, so you don't even have to write it down if you don't want to. Okay? You got lots of practicing to do. So this is 3.7 natural log derivatives. Ln of x derivatives.
Am I doing logs at all?
Well, we've already talked about ln, right? So I could just give you an ln function, and yes, you should be able to give. We already know that though, right? Y equals ln of x gives me what? Y prime is what? 1 over x, right? So the tricky thing to think about is if y equals the ln of u, it's not that easy to get that y prime is u prime over u. And this is the whole thing. The ln trick is, how do you take a derivative of a natural log? You take the derivative of the inside over the inside. So I mean, just memorized is all I want. How do you use it is simple. Derivative of the inside over the inside. So I'm gonna derive that formula. Again, you don't have to write this. I'm not testing you on it. Okay? If you want to show off on the test, use it, and I'll show you where you can use it. If you want to show off. Okay? So I want to get the derivative of this thing, right? But I don't really know how to. I think the answer is 1 over u, but that's not true because u is a, right? Yeah, u is a function. So I'm going to rewrite it using what function? E, base e, right? So I'm going to raise both sides to base e, just like we did all the time in pre-cal, right? We're always using those two. Why are those two functions special? Ln of x and e to the x. What's their relationship? Inverse. They're inverse functions. They cancel each other out. So what happens on the right side here? I just get u, right? The e to the x and the ln of x cancel to get me x, right? So I get e to the y equals the function u. Some function of x, right? I don't know what it is. It's hidden. But I do know if I take the derivative of it with respect to x, on the left, what do I get? Beautiful, y prime times e to the y. And on the right? U prime. Nice. So y prime is now u prime over e to the y. Do I know what e to the y is? It's on my page. Do I know what e to the y is? U. So there it is, u prime over u. Derivative of the ln function is derivative of the inside over the inside. Derivative of the inside over the inside. So again, remember I said find u prime, find u squared, plug and chug. Now I'm saying, give me the derivative of the inside divided by the inside. Done. Don't have to think about it. Right? We okay? Good, let's do a problem, right? There's my y equal. Normally I would solve this using what? Product rule. I want to do it once with the product rule on my own, right? Like this problem from Thursday. Yeah, problem 2 from Thursday. Make sure you do that because it's on the quiz. I'm going to change it, but it's going to be the same type of problem. Don't FOIL it out. Don't distribute factor, please. Yes? So I'm going to do the ln trick here. I'm going to take the ln of both sides. This is my ln trick. ln of both sides. So I get ln of y equals, when I'm multiplying the argument of an ln, of a log, of any log, I can split it into the sum of logs, right? From pre-cal, we remember this? This is the ln of 2x minus 1 quantity squared plus the ln of 5 minus 2x quantity squared. You remember doing that? The properties of natural logs in pre-cal? Jeffrey, you remember that? Yeah. Yes? There's another property of logs. What can I do? This guy's a square here, right? What's the other property of logs that I can use? Yes, I can bring powers in the argument of a log out as coefficients. So I get the ln of y equals 2 times the ln of 2x minus 1 plus 2 times the ln of 5 minus 2x. If you don't remember doing this, your teacher skipped it because you did it so many times in pre-cal. Right, Sina? You remember doing this? You do? Who was your pre-cal teacher? Oh, yes, I tortured you with this stuff. Why? Because I knew you were going to be a calculus class student. You have to be able to do all this crap. I'm ready now to take my derivative. I'm ready to take the derivative. This is the ln trick. The ln trick is to take the ln of everything first. So I want to do derivative of the left side, and that's going to give me the derivative of each piece on the right side. And what's my process for an ln derivative? I get the derivative of the inside over the inside. So on the left, what do I get? Y prime over y. Yes? On the right side, first part, 2 times what? 2 over 2x minus 1, right? Derivative of the inside over the inside, yes? Plus 2 times what? Good, negative 2 over 5 minus 2x. Derivative of the inside over the inside. And there was a coefficient out front. Let the coefficient go for the ride, right? So look at this. It looks like I have y prime equals y times 4 over 2x minus 1 minus 4 over 5 minus 2x. Am I done? Hell no. I definitely have fractions within fractions. And I also know what y is, right? I know what y is, right? It's 2x minus 1 to the second, and there's a 5 minus 2x to the second. And I'm multiplying that to 4 over 2x minus 1 minus 4 over 5 minus 2x. I'm going to take one of each of my factors and distribute it in. And I'm going to take my 4 and factor it out. Yes, you with me? I'm going to take the 4 and factor it out. You see that part? And I'm going to take a 2x minus 1 times a 5 minus 2x and put it inside. So I took the 4 out by factoring. I'm going to put a factor of 2x minus 1 and a factor of 5 minus 2x in. You with me? Factored the 4 out. I distributed 2 other factors in. Yes? See anything happen? Yes, that's why I did it, right? I'm trying to clear fractions. So it looks like I have 4 times a 2x minus 1 times a 5 minus 2x, and then inside I have 5 minus 2x minus the quantity 2x minus 1. So inside there, I have to see if it factors. It looks like I get a negative 2x minus another minus 2x, so that's negative 4x, right? Yes, and then I get a 5 minus a negative 1, that's 6. So I'm going to take out a negative 2. Done. Make sure you do that one over with the product rule to practice for the quiz, right? Brian D is not here. Johanse's not here. Everyone else is here. One more problem. Yes, you better. It's an alternative method, yeah. Yep. It actually works for quotient rule too. Because when you do ln of A over B, you get ln of A minus ln of B, right? So it would work with the quotient rule too. Yeah, it actually, I think it's easier than the way we've been doing it with the product rule. And like I said, if you want to show off on the test, you can use the ln trick. I don't care if you use it. I'm not asking you to use it though. Last problem. I promise, I might have said last problem before, but I mean it this time. I swear I mean it. He's a liar. Let's say y equals x to the x. Let's find a tangent line here when x is 2. What do you think? What is this? What kind of rule is this? What's that? It's definitely, it's always a chain rule. Forever and ever and ever. Chain rule for the rest of your life. Even when you're walking, it's chain rule. I'm moving because my brain is changing. It's saying move. Right? So is this a power rule? When you have a power rule, what is the power? It's a number, not a variable. Is this an exponential rule, like e to the x? What's the base when it's an exponential? A number. The base is a number when it's exponential, e to the x, 2 to the x. When it's a power rule, it's x to the 3rd, or x to the 7th, or x to the minus 1. So this is an issue here. We don't know how to deal with this. But we do know if we took the ln of the right side, we could use the properties of the natural log function to simplify it. So that's what we're going to do. We're going to use an ln trick. I'm going to take the ln of y, and that should equal the ln of x to the x. Why is that true? When is that true, by the way? When am I allowed to take the ln of both sides? When the function is what? Say it again. A little louder. Are you saying 1 to 1? Is that another way to say 1 to 1? 1 to 1. When the function is 1 to 1. Look at the function. Oh, is it 1 to 1? No. Damn it. No repeated heights is 1 to 1, so that didn't work. But is that really what the function is? Yes. So I'm wrong about that. I got to think about that. Well, continuous. Certainly, if it's continuous, I can do it for sure. So what happens on the right, though? What happens to my exponent? Where does it move? Out to the front as a coefficient. X times the ln of x. And now I'm going to take a derivative. What do I get on the left side? What's the derivative of ln of u? It's u prime over u. It's the derivative of the inside over the inside, right? So y prime over y, yes? And on the right side, I need a product rule, yes? First function is x, derivative is 1. Second function is ln of x, derivative is 1 over x. So I get 1 plus ln of x. Yes? Good. So my derivative is x to the x times 1 plus ln of x. right? I cross multiplied with y, yes? And y was x to the x. Good, so I have x, right? I need y, and I need the slope, yes? So I know x is 2, I know y is 2 to the 2, which is 4, right? And I know m is, sorry, that's x to the x, not x squared, Robert. Right, x to the x is y? Sorry. So I get 2 to the 2 times 1 plus ln of 2. So I get 4 times 1 plus ln of 2. So tangent line y minus 4 equals 4 times 1 plus ln of 2 times quantity x minus 2. Right? We okay here? Doesn't get much prettier than this. I think that's the nicest way to do it. If I start distributing it out, it just gets ugly. On Desmos, I've got the point 2 comma 4, right? Yes? And I have the tangent line of y equals 4 times 1 plus the ln of 2 times the quantity of x minus 2 plus a 4. Boom, tangent line. Oh my God, you made it. I'm proud of you. Only one student could